Complex zeros, we'll get into the fundamental theorem of algebra, but what are complex zeros? Somebody tell me, what's a complex zero? A complex zero, let's just go here, is a number that can be expressed in the form a plus bi. It's your imaginary numbers. It's a zero that's your imaginary number, okay? So when you think about your imaginary numbers, okay, think of it in terms of a graph. So your x-axis is your real number system, okay? And your y-axis is your imaginary number system, okay? And so then the complex root, your real numbers are the a's, and then your imaginary for this point here are your b's. Okay, does that kind of make sense? All right, so your a and b are real numbers. I is the imaginary unit, and it satisfies this equation of I squared equals -1. Because basically, that unit right there, or that equation right there, is what lets us move back and forth between our imaginary and real number systems, okay? It's like we can translate back and forth between the two. Alrighty? Okay, the only thing we're doing today are the rules for sum and difference and multiplying, basically practicing your FOIL. So, sum and difference is your addition and subtraction, right? So all you do is combine your real like terms. So the first number is my real numbers. So I have 3 and -2. So I have 3 minus 2. Okay? Then I'm going to combine my imaginary numbers. This one I'm adding, so that just stays the same in between. And so now I have 5i plus 3i, which then just gives me my answer of 1 plus 8i. Okay, good, easy peasy. Lemon squeezy. All right, now, when you're doing a subtraction, okay, you just move your subtraction down kind of thing, and then you just move your numbers over. So this becomes 6 plus 3, and then it's going to be 4i plus 6i. And so then I'm going to have 9 minus 10i. Okay? You just take, basically, you move your sign that you're doing, whether it's adding or subtracting in between, down beneath the two, and then you combine your like terms. So if you have one that's like 3 plus 4i minus a -6 plus 2i, that's like saying 3 minus 6 minus the 4i plus 2i. Okay? So just take the sign in front for in the middle here. 6i. Okay? Good? Easy peasy? All right. Product. What's it mean to be a product? Multiplication. What do you do when you multiply two binomials? Like here. FOIL. Okay? All right. So, I'm going to have my first, which will be 5 times 2. And then I'm going to have my outer, which will be 5 times 7i. Then I'm going to have my inner, which is going to be 3i times 2. And then I'm going to have my last, which is going to give me 3i times 7i. Okay, everybody good so far with that? Okay, when I simplify, I'm going to get 10 plus 35i plus 6i plus 21i squared. And I can combine these two like terms, so I have 10 plus 41i plus 21i squared. Good so far? Okay, here's the trick question. Imaginary numbers are only a plus bi. There's no I squares, right? So that means I need to have it in a plus bi form. Okay? But remember what I said about transferring back and forth between imaginary and the real number world? You use this equation. If I squared is equal to -1, what do I want to do in my equation? Huh? Beautiful. Perfect answer. So 10 plus 41i plus 21 times -1. 3i times 2. How'd I get what?
35. 5.
5 times 7i. Okay, by outers. Okay? Alright, now that makes this a -21. So now I have 10 minus 21 plus 41i. And so I have -11 plus 41i. Now I'm good, because now I'm in that a plus bi form.